Hello everyone. In today's lecture we are going to study Tesla coil, and we are going to cover the theoretical concepts, the practical circuit, and the key knowledge, everything about the Tesla coil which you should know from theoretical concepts to the practical concepts. We are going to cover in detail in this lecture video. Well, Tesla coil is very important when you are studying the high voltage engineering, and Tesla coil is actually used to generate high voltage and high frequency AC. Okay, the benefit of Tesla coil is that you can generate high voltage as well as high frequency AC voltage. First, before we proceed on, let's discuss about who invented this. And Nikola Tesla proposed the concept of Tesla coil. He proposed the concept of Tesla coil experiment back in 1891. And this Tesla coil is also known as this experiment is also known as high frequency resonant transformer, and it is also known as doubly tuned resonant circuit. Now, in our previous video lectures, we discussed high frequency resonant transformer, and today I am discussing the Tesla coil. Now, what is the key difference between high frequency resonant transformer and the Tesla coil? Though Tesla coil is also referred sometimes as the high frequency resonant transformer circuit, but it is not actually. High frequency resonant transformer circuit is also used to generate high voltages, and we have discussed it in our previous video lecture. If you are willing to study that, you can refer to my previous video. And Tesla coil actually is second name is doubly tuned resonant circuit. Okay, so let's first discuss about what is actually the Tesla coil is. Now I am going to draw the basic circuit representing the experiment of the Nikola Tesla, and we will lead from that circuit to the practical knowledge or the practical concept. So here we have the basic circuit of the Tesla coil experiment, and this circuit was proposed by Nikola Tesla in 1891. Now you can see that, and this is what the experimental setup which you will be using in your lab for the practical demonstration. You can use this, but this is not actually the practical experiment. The exact circuit which we should use, it is somehow the different one, because this circuit, okay, it works, it generates the output voltage according to our desired results, but it has certain limitations due to change in environmental conditions. Let's first understand this circuit. When we will be having the basic understanding, then we can proceed on for the most practical circuit. Now this is the Tesla coil experiment circuit. You can see that here you have two capacitors, the capacitor C1 and the capacitor C2, and these are actually the high voltage capacitors. And here you can see two inductors. Actually here we have a transformer, and this is an air core transformer. Actually this is not an oil immersed transformer. And why it is an air core transformer, we will be explaining that. And this is an air core transformer, and the M indicates the mutual inductance between these two inductors. Now this air core transformer means that here you have two coils or two windings, the primary winding and the secondary winding, and these windings or this air core transformer is oil immersed. It is immersed in oil. Now why this transformer is immersed in oil? Because of the purpose of cooling. Okay, so now here you have these two capacitors, these inductors making the air core transformer, and this is the spark gap, and this gap is actually adjustable. You can adjust the distance between these two gaps, and the surface of the electrode here is the spherical surface. Normally you use spherical electrodes as the gap, and here you have an AC supply. Let me explain you a bit more about this circuit. Like, this is the primary winding and it has only the few number of turns, and this is the secondary winding, and here the number of turns are around if here normally L1 this winding comprises of around 10 to 20 turns only, and this inductor has around 1000 to 1500 turns on the secondary side, and this is the primary side. And now let us first observe at the output voltage waveform, and then we will be discussing how this circuit actually works. Now output voltage waveform of this circuit is like that. You get high voltage and high frequency sinusoidal waveform, but that sinusoidal waveform is in the form of damping. This is actually the damped sinusoidal waveform. It has this is a graph between the voltage versus the time. Here you have time axis and here you have voltage axis, and the voltage here is around kilovolts, and you can see that the voltages are damped. Now how this circuit is able to produce this type of waveform? For that you need to understand what's inside this circuit, what's happening here. So you can see that here you have a damped sinusoidal waveform. And one more thing I must share you before we move on. The input voltage range, the primary voltage here you apply is around 5 to 10 kilovolt, and the voltage here we get it is around 1000 kilovolts, and it can be more, it can be up to 1000 kilovolt. And the frequency of this sinusoidal waveform is around 50 kilohertz to 1 megahertz. So this is the frequency range. There can be the frequency between any between 15 kilohertz to 1 megahertz, and the input voltage is around 5 to 10 kilovolts. And this is, here we have an oil immersed transformer. So now let's understand the working, that how this Tesla coil is actually working. So at start what happens? Now at the start what happens? The current flow in this direction, because you have adjusted the spark gap. First you need to adjust this spark gap to a voltage level such that its breakdown voltage is more than the voltage you are going to supply here, the AC voltage you are going to supply here. Okay, so the spark gap is open circuit at the start. What happens? This capacitor charges. Now you have the capacitor and inductor in series. You know, the capacitor opposes the change in voltage across it, and the inductor opposes the change in current through it. Okay, at first this spark gap is open, is behaving as an open circuit. what happens, the current flows in this direction through capacitor, the AC waveform flows in this direction, and since this inductor L1 has just 10 to 20 turns, so it will behave just like an open it behave just like a cable or just as a conductor. It will not be behaving, it will not be showing its inductance property. Why? Because the frequency which we are supplying here is the power frequency. This is 50 hertz. So frequency you have is just 50 hertz. So at 50 hertz, if you have just 10 to 20 turns and you have a capacitor as well, so this inductor will not start behaving as a inductor. And so what happens, the current flowing here. Now what's next? This capacitor gets charged. Now when the capacitor gets charged, what is happening? Although there is when this capacitor gets charged, there is an inductor as well in series, and it has the induced EMF in it. What happens when the voltage here is greater than the spark gap voltage? What happens? This gap breaks over. There is a spark across this gap. Now when there is a spark, now what happens? This is the capacitor L and C and L. Now what happens? They actually synchronize each other, or you can say this is like a tank circuit. Now what happens? The voltage here increases as I told you that this capacitor, what it does, it opposes the change in voltage across it, and inductor opposes the change in current. And we have carefully chosen this capacitor and inductor in such a way that there appears the resonance. And when there is the resonance, what happens? There is a resonance. Resonance means that it behaves like a tank circuit, and upon resonance the voltage here rises in this manner. So the waveform we are getting on the primary side here is like the voltage, this voltage is appearing. And since you have used we have used this transformer, and here we have the high frequency, because now inductor and capacitor will exchange their energies at a very high frequencies. So when you have a high frequency, then the transformer size reduces, and that's why we have used the air core instead of the iron core, because you have the high frequency here. And the voltage waveform on the primary side is also similar to this waveform, but since here there is a mutual inductance, and due to high frequency the mutual flux is more. So what happens? The voltage here is actually the stepping up. The voltage here is transformed to the high voltage level. And one thing which we have which we need to take care is that about the oscillation frequency or the resonant frequency. The resonant frequency of this inductor and capacitor must be matched with the resonant frequency of this circuit. Now what happens when this circuit is resonating and the voltage here is matched with the resonant frequency of this inductor and capacitor? What happens? This circuit also resonates, and the voltage here we are able to get a very high voltage on the output side. This is how this circuit works. Now one thing more I should explain here is that now when the voltage across this capacitor is more than is able to break the spark gap, what happens is that once the spark gap is conducting, this inductor and capacitor exchange their energy, and we get a high voltage, high frequency waveform like this. But since you know that due to some practical losses of the resistance in the conductor, the waveform get damped, and similar waveform is transformed on this secondary side. One thing that is important is the proper tuning. the capacitor and inductor values are chosen such that they resonate at the 50 Hertz frequency, and this inductor and capacitor, they are chosen such that their resonant frequency also matches with here resonant. And what happens next? You will see the development of the high voltage high frequency waveform. So this, the resonant frequency on the primary side, if it is 50 Hertz, now since after the resonance, this is the resultant frequency, and that resultant frequency must be matched with the frequency of this inductor and capacitor. So here is the basic working of the Tesla coil experiment. And here we have some key factors which are need to explain more, like once this spark gap conducts, it again becomes open circuit when the potential drops the level of this breakdown voltage. And as I told you at the start, this gap behaves an open circuit. Obviously it behaves an open circuit, and this capacitor is getting charged. Now you know that this inductor also has the induced EMF because it opposes the change in current. So that induced EMF and the voltage of this capacitor is more than the supply voltage. So due to that, the spark gap breaks up, and once this spark gap sparks over, that is it starts conducting, this inductor and capacitor are now in parallel to each other. When they are in parallel to each other, what happens? They resonate. How they are able to resonate? Because once the supply frequency is 50 Hertz and we have chosen the values of C1 and L1 such that they resonate with each other. Once they resonate, the resultant voltage and frequency is very high. Let's say the frequency in this circuit reaches around 60 kilohertz. So the frequency here is 60 kilohertz. Then it means that here what will be transferring the 60 kilohertz frequency. Now this inductor and capacitor are chosen such that they must resonate on the 60 kilohertz frequency, and once they resonate, then again here you can get a high voltage, because the waveform which is transformed here is actually the stepped out, because here you have less turns and on the secondary side you have more number of turns. So the output waveform not only transforms in its voltage but also further because of the resonance between this inductor and capacitor. So the resultant frequency here, it can be so the resultant frequency here will be the 60 kilohertz, because now they are excited on this level of the frequency. So these are some practical, so this is actually the basic the circuit of the Tesla coil experiment. One more thing to add is here, what are the practical limitations here, as once this spark gap breaks up, the air around this gap ionized, and then this spark gap, it is quite possible that this gap will spark over again at a lesser voltage as compared to the previous voltage, because now the air is ionized, and the ionized air requires lesser breakdown voltage as compared to the air which is not ionized. And moreover, due to the once you start getting the voltage here, this capacitor also heats up. There is the temperature of this capacitor rises, and because of these temperature effects, these values deviate from what the values you have theoretically. So what happens, you in some situations that you are unable to reuse this circuit or reuse this experiment again and again for the desired level of the voltage, because then the resonant frequency changes. So this circuit has the practical limitations. So practically we don't use this circuit, rather than that we involve the power electronics circuitry here, which we are going to discuss in our next video lecture. and we are going to explain the more practical circuit of the Tesla coil. This is the basic circuit of the Tesla coil, which you can found in your textbooks. And the circuit now we are going to cover up in our next video is a different circuit, and that is what the real circuit which we use in our labs. Okay, so stay tuned. If you haven't subscribed to this channel, I will request you to subscribe so that you get timely notifications about the high voltage engineering lectures, as well as we are also going to start a series of interview questions as well on this channel. So thanks.